Hello, we'll make a presentation on the development of a deep learning-based diagnosis and training mobile app for the communication deficits. The presentation will proceed in the order of research introduction, training and content design, learning algorithm, UI/UX development, and future plans. First, we'll start with the research introduction. The project we are undertaking is the development of a mobile application for deep learning-based diagnosis and training of communication deficient individuals. The research period is scheduled to be from March to August 2023. Our research focuses on individuals with communication impairments, especially targeting their difficulties in medical communication, qualitative interaction, and expression of emotions. In this project, we aim to enhance the social communication abilities of individuals with communication deficits. To achieve this, we propose a diagnostic and training platform that utilizes deep learning techniques to analyze their facial expressions and behaviors. By leveraging deep learning technology, we aim to provide a comprehensive understanding of their communication challenges and offer tailored training content to provide their communication skills. Through this project, we strive to make a positive impact on the lives of communication deficits by empowering them to effectively express themselves and engage in meaningful interactions with others. Firstly, let me explain the necessity of this research. Individuals with communication deficits, including adolescents and adults, experience a lack of social communication skills, which results in difficulties in both verbal and non-verbal communication, establishing and maintaining interpersonal relationships, and fulfilling social needs due to a social isolation. This can lead to problems in communication and interaction with others, and financial issues and hindrance in achieving social fulfillment. Existing diagnostic and training platforms for individuals with communication deficits rely on the reactions of these individuals in games or indirect methods during cognitive assessment, requiring the assistance of caregivers. However, to directly diagnose and train individuals with communication deficits based on their overt responses, such as facial expressions and body language in real time, a deep learning-based platform that analyzes their behaviors and utilizes them becomes essential. Next, I would like to discuss the concept of training functionalities and contents. We have devised content consisting of multiple problem scenarios to assess the emotion recognition and expression abilities of individuals with communication deficits. The purpose is to improve their skills by solving these problems. Using deep learning-based algorithms, the app analyzes the physical cues exhibited by individuals with communication deficits to determine if they have appropriately performed expressions related to specific emotions. The app uses music and facial expressions to train individuals with communication deficits in emotion recognition and expression. Users choose the facial expression that matches the music, and by mimicking these expressions, they can effectively learn emotional cues and expression techniques. Using a deep learning-based facial expression recognition algorithm, the app analyzes the expressions of individuals and provides feedback on their appropriate needs, assisting them in improving their expression skills. I will now explain the need for facial expression recognition-based diagnosis and training. Communication deficient individuals struggle to differentiate facial expressions and emotions, which hinders their social emotional interactions. By providing diagnostic and training content based on facial expression recognition, we offer the functionality for communication deficient individuals to mimic facial expressions corresponding to specific emotions. This enables the diagnosis and training of their communication abilities. Let me explain the process of emotion recognition-based diagnostic and training content. Firstly, for each question, we play music that predominantly reflect a specific emotion's mood. After listening to the music, the individual is presented with three choices, represented by characters expressing different facial expressions corresponding to specific emotions. They are then prompted to select the option that best matches the mood of the music. If the individual chooses the appropriate option, they proceed to the next question. However, if an inappropriate choice is made, the music is replayed, allowing them to select a different option. Through this process, we aim to enhance the individual's emotion recognition skills. Next, after choosing an option, there is a process where the individual imitates the corresponding facial expression. Following the selection, the individual is encouraged to express the emotion directly related to the previous music. The character's face and the rear camera are used to project the individual's own face onto the screen, and within a limited time, they are asked to mimic the specific facial expression associated with the chosen emotion. If the self-made expression matches the intended emotion, they proceed to the next question. However, if the expression is deemed inappropriate, they are given the opportunity to retake the expression. To determine whether the facial expression of the individual corresponds to the intended emotion, we utilize a deep learning-based facial expression recognition algorithm. The captured facial images of the individual are input into a pre-trained deep learning model specifically designed for facial expression recognition. The model infers scores for each emotion category based on the input images. If the score for the corresponding emotion exceeds the predefined threshold, it is considered that the individual has expressed the correct facial expression. However, if the score falls behind the threshold, it is considered that the facial expression was not appropriate, and a retake is required. Next, let's examine the body motion recognition-based diagnostic and training content. Initially, when a specific music is provided to the individual, they are prompted to play the instrument corresponding to the rhythm by pressing the designated buttons on the screen. The individual's body is recognized through the front-facing camera, and when they extend their hand to reach the displayed instrument buttons on the screen, they are able to play the instrument. Using a deep learning-based hand recognition algorithm, we verify whether the hand's position has reached the instrument buttons, enabling the individual to play the instrument accordingly. The need for such content arises from the fact that individuals with communication impairments often exhibit inadequate or inaccurate imitation of specific movements due to symbolic cognitive deficits. Inaccurate movements result in imprecise bodily expressions, leading to difficulties in communication and social interaction with others. Therefore, There is a need for content that utilizes a deep learning-based hand recognition algorithm to train individuals with communication impairments to position their hands correctly on the buttons, ensuring precise body movement for effective communication. First, let me explain the process of the body motion recognition based diagnostic and training content. We ensure that the individual's body recognized through the front camera is positioned in the center of the screen. This allows for accurate tracking and analysis of body movements. Next, buttons that enable instrument playing are displayed on the camera screen when the individual positions their hands appropriately. As the music plays, the individual reaches out their hand towards the buttons on the screen, where the corresponding instruments are displayed, and performs the appropriate playing action. By accurately detecting the position of the hand using a deep learning-based hand recognition algorithm, the individual is able to play the instruments in a precise manner. Now, let's take a closer look at the process of score verification. By utilizing a deep learning-based hand recognition algorithm, we ensure that the hand is positioned on the buttons displayed on the screen, enabling the generation of musical notes when played. We verify whether the individual has played the appropriate instrument in sync with the played music. This is done by comparing the recorded performance with the expected performance for accuracy assessment. The performance score is then recorded, allowing for a comparison with previous scores. This comparison helps determine the level of improvement in the accuracy of the performed actions. Uh, let's take a look at deep learning algorithm. The model we use is called the Learnable Graph Inception Network, which is a graph-based model for classifying emotions from video or image data. Our proposed approach involves transforming the image data into a graph format and feeding it into the model, allowing it to capture the dynamic aspects of facial expressions. The model is trained to classify emotions into 6 categories: anger, disgust, fear, joy, sadness, and surprise. The structure of the model is as follows. First, the transformed data in the form of graph will pass through the multiple graph convolutions arranged in parallel in a graph inception network. The results obtained from each graph convolution are then concatenated along the channel dimension and undergo different pooling methods. After that, the data goes through a fully connected layer to ultimately predict the emotion. Next, let's take a look at the deep learning-based hand recognition algorithm. The model we use is called Dynamic Graph-Based Spatial Temporal Attention, abbreviated as DGSTA. This model considers the skeleton, which is the key region of the hand, as nodes and edges in a graph. It dynamically captures the hand's position and temporal changes to recognize hand gestures. DGSTA extracts spatial-temporal position embeddings from the input images or videos of hands, capturing both the location and temporal information. This allows for more effective information transmission to the nodes in the graph representation. Additionally, through a spatial-temporal mask operations, dot product computations are performed on all nodes, resulting in improved computational efficiency. Let's now take a look at the UI/UX development aspect. The left image represents the starting screen of the facial expression recognition-based diagnostic and training content. while the right image provides an explanation of the content. The starting screen of the application, as shown in the left image, serves as the entry point for users. It presents a visually appealing interface where individuals can begin their journey of facial expression recognition, based diagnosis, and training. The screen may feature a captivating background image along with intuitive navigation elements that guide users through the various sections and functionalities of the app. On the right side, the image showcases the explanatory section that accompanies the content. This section aims to provide users with a clear understanding of what the diagnostic and training content entails. It may include textured descriptions, graphical representations, or even short video clips to effectively communicate the purpose and objectives of the content. The explanatory section serves as a helpful resource for users, ensuring they are well informed and prepared to engage with the subsequent activities and exercises. The left image represents the stage where users are required to choose a character that best expresses their emotions, similar to the music being played. Users are presented with a set of options, each featuring a character depicting a specific facial expression. Their task is to select the most appropriate expression that aligns with the emotional tone of the music. The selection serves as the gateway to the second stage, where users will have the opportunity to directly imitate and reproduce the chosen expression. On the right side, the image showcases the screen that provides an explanation of the second stage. This section aims to guide users through the process of imitating and expressing chosen facial expression. Next, we have the diagnostic and training content based on body movement recognition. The left image represents the screen where users can choose from a list of music they want to play. It provides a selection of songs or playlists that users can browse and select according to their preferences or specific training goals. This screen allows users to personalize their experience by tailoring the music to their liking or focusing on specific areas of improvement. On the other hand, the right image showcases the screen that guides users to position their body correctly. It serves as a visual reference, encouraging users to align their body posture, gestures, or movements with the designated guidelines or markers displayed on the screen. Once the user's body is recognized as shown in the left image, the system detects the user's hands and displays buttons on the screen that enable them to play musical instruments. These buttons correspond to different instruments or notes, allowing the user to engage in a virtual musical performance. On the right image, we have the screen where users can check their performances scores after completing the musical rendition. This screen presents a summary of the user's performance, including metrics such as accuracy, timing, and overall proficiency. Next, let me share our future plans. We have completed the design of the training features and content so far. We are currently developing the UI/UX and deep learning models. Starting next month, our plan is to generate the outputs, execute the mobile app, conduct testing, and gather feedbacks. That concludes the presentation. Thank you.